Uh, Good morning, students. Welcome to the next lab session. Today we're going to perform an RC phase shift oscillator. I think you will be familiar with this kind of circuit. This is an amplifier, common emitter amplifier, and this is an RC network. You know the purpose of amplifier is to amplify the signal, and basically amplifier introduce a 180-degree phase shift at the collector terminal. And the purpose of this RC network is to introduce another 180-degree phase shift so that it cancels out at the input. That is, there will be a positive feedback with respect to the input. So if you ask me what is an oscillator is nothing but an amplifier with a positive feedback. An amplifier introduces a 180-degree phase shift with respect to my input, and this feedback network introduces another 180-degree phase shift, so the input is in phase with the feedback signal. So we call it as a positive feedback. There would be a question like we don't give any input as such. So how we are getting a oscillation or sine wave coming at the output? Very simple. As such, there is no input, but there will be a slight disturbance due to the components present here. That signal is being picked up by the transistor and that will be amplified. For example, a very small noise can also be amplified, and this again in turn will be a feedback. So this actually goes until my A beta, it is what you call this a loop gain. A the gain of the transistor and beta the loop gain, feedback gain is 1. So you get a sustained oscillation at the output of my capacitor here connected at the collector. So let us see the frequency that is being generated by this particular network. The frequency of oscillation is given by 1 by 2 pi r into c and root of 6 plus 4 rc by r. And we want to suppose, for example, the required frequency is 1 kilohertz, and we are going to assume r as 4.7k. Why? Because we are going to avoid the loading of this RC by the RC network. And when you calculate by the known value of R and RC, we can calculate the value of the capacitance to be put, which is around 0.01 microfarad. So this is a basic setup. So basically we're going to give a DC volt of 12 volts. So that's the only input we're going to give, and rest the noise is being amplified. That's what the oscillator is. And why we having three RC networks is each RC introduces a 60-degree phase shift. So in turn 60 plus 60 plus 60, which comes to 180-degree shift. So let us see the connections. The connection is being given, and we have the resistors, capacitors, which forms the feedback, which is given to the input of the transistor. And you can see the output. You can see the amplification, oscillation, sine wave being generated by the oscillator. If you see the frequency comes to around 1 kilohertz. So that's the desired frequency. Thank you.